Hello guys, this is Tamaskan, and today we're going to talk about thermodynamics, which is a really interesting topic. So yeah, we've been covering different topics, but for today we will focus on this term thermodynamics, which is quite a broad subject, but we'll try to cover the specific points or the main concepts or the mandatory points that are necessary for this introduction part. So stay with me. So let's go thermodynamics. Like it's all about hot and cold. Like we all know, heat flows from hot to cold. Yeah, this is a simple term. So let's go to the first thing, thermodynamics. Thermodynamics is the study of the effects of work, heat, and energy on a system. It studies the effect of work, heat, and energy on a system, thermodynamics. And here, thermodynamics is only concerned with macroscopic, large-scale changes. Actually, we will see about thermodynamics approaches, the microscopic and macroscopic. So don't worry about this thing here. So let's see some of the applications of thermodynamics. It could be IC engine, power plant, gas turbine engines, water dam, refrigerator, air conditioner, food processing unit, submarines, aircraft, spacecraft, automobiles, human system. So like this kind of broad topic, as I said before, when we talk about thermodynamics, it starts from the IC engine to human being, to gas turbines, to submarines, different various applications. That here we will try to focus on the basic terms that we can make us easily understand thermodynamics. So let's see classical and statistical thermodynamics. Like actually, classical thermodynamics concerns the relationship between the bulk properties of a matter. Nothing is examined at the atomic or molecular level. So if we are talking about the classical thermodynamics, we are talking about the bulk properties of the matter. We don't care about the atom, or we don't care about the molecules. But if it is statistical thermodynamics, seeks to explain those bulk properties in terms of the atom, like the aggregation of atoms, not the behavior of individual atoms, but the aggregation. Okay, aggregation of atoms. So to make it more clear, let's see here the approaches, the macroscopic and microscopic. So we have macroscopic approach, and also we have microscopic approach. This one is classical thermodynamics, as we were saying before, and this one is statistical thermodynamics. So here it's about gross or overall behavior. Like you take the element as it is and you try to study. Let's say if this is the element, in terms of thermodynamics concept, we just analyze this element as it is. We call it this microscopic. But if we are talking about this statistical thermodynamics, which is average behavior of large groups of individual particles, we focus on the individual particles or the aggregation of atoms. This one is simple mathematical formula. This one is advanced statistical and mathematical tools, and properties can be easily measured using instrument. We can measure its mass, its density, or something easily if it is macro. But if it is micro, the properties cannot be measured by instruments. So it's really hard for us to simply measure the properties as long as they are at microscopic level. And here, change in properties cannot be easily felt by our sense. If there's a change in the property, we can easily sense it. But here at macroscopic approach, we can easily felt if there's a change. And also, the other thing is very few properties are required to describe the system. It could be mass, density, or volume. We just need very few properties to describe the system. But in microscopic, large number of properties are required to describe. We need different various properties to describe the system right here. So as you can see here, we have the microscopic approach or molecular level, but this one is macro. This is solid element, so we have the pressure and volume of this element. And if we see here, we have the atoms. They have their own mass, they have their own density. So it's all about like microscopic world to macroscopic world. We have the position, the velocity, and the mass of the atoms, but here we have the pressure, the volume, and the temperature, and the moles of the solid element. So this is the difference between the two approaches, the classical and the statistical thermodynamics, or the macroscopic or microscopic approach.